Welcome to Newline99. We're going to take a crack at making a series of videos about using the TI Editor Assembler. Before this video, I did put up an assembly introduction video that you might also find helpful. This video will have a few fundamentals. While the basic programming language is meant to bridge the gap between the computer and the average user, assembly language is meant to provide a more experienced user low-level access to every possible function of the computer. But while BASIC knows a lot of ordinary functions, for example, the command print is used to output to the screen, and input accepts input from the keyboard, assembly doesn't automatically have a print or input. It's up to you to tell it how you want that done, and you'll have to learn a lot of new operations and symbols. Assembly in general is a programming language where the instructions that the user enters directly represents the processor's own machine code. Let's say that the TI-99 CPU is about to run machine code that looks like 02000004 in hexadecimal. The processor knows that this code means to load the value of 4 into register 0. This machine code can be constructed using assembly language through symbols. LI for load immediate, R0 for register 0, comma 4, which is the value we want to load. When the assembler creates the object code that the processor will use, it contains that exact machine code, 02000004. It's a lot easier for a human to read and remember the abbreviation LI as load immediate. The core of the TI Editor Assembler runs on the cartridge. Use the main menu to navigate the options. When it comes time to load either the editor or the assembler, those are programs that reside on the accompanying floppy disk. It can be a little tedious, but each time that you load the editor assembler programs or access your own programs, you have to switch disks. Select one to edit. Insert the editor assembler disk to load the editor. Switch to your own disk, load your source code, and then edit your code. Then when you're done, you can save your code, press 2 for assemble, insert the editor assembler disk again to load the assembler, switch disks again to select your code, and assemble it into object code. With your code disk still inserted, you can press 3 for load and run. Select your object code, select your starting program name, and your program starts up. Of course, all of this disk swapping stuff goes away if you're lucky enough to own more than one disk drive. Editor Assembler uses a lot of the common TI function keys. Function 1 deletes text starting at the cursor position and shifts following characters over. Function 2 inserts characters, allowing you to insert text before the cursor position. Function 3 will delete an entire line. Function 4 and Function 6 pages up and down. Function 5 shifts the page to the right. Function 7 moves the cursor position to the next tab. Function 8 inserts a blank line before the cursor. Function 9 escapes the current screen and exits to a previous level menu. Pressing it once in the editor gives you access to lots of editor features to move and copy text. Press it again and it takes you out of the editor. When you're at the beginning of a line in the editor, if you press left arrow, it will turn on or off line numbers along the left margin. This is useful when going back to fix errors that have been detected during assembly. If you plan to program in assembly language, you will do well to familiarize yourself with the numbering systems, binary, decimal, hexadecimal, and ASCII conversions. As humans, we evolved with 2 hands, 10 fingers total, and because of that we naturally developed a numbering system that's based on tens. That base 10 system is also called decimal. But then we invented computers and had to reconsider our numbering system. Computers represent numbers using sequences of on and off electric signals, ones and zeros, introducing a practical use for a base 2 or binary system. It soon became more advantageous to use numbering systems based on factors of 2 in programming, and the numbering system that really caught on in the computer industry was base 16 or hexadecimal. The first 10 symbols in hex are the same 0 through 9 digits we're familiar with in the decimal system. But now there are 6 more digits to symbolize, so we use characters from the alphabet A, B, C, D, E, and F. And when counting up, after you get to F, you flip back to 0 and carry a 1 to increment the next place. So that 10 figure that we've grown to love as meaning 10 actually represents a number 16. 19 in hex, and it keeps going from there. So how do we represent things that aren't numbers? Well, that too is a numbering system. ASCII, the American Standard Code for Information Exchange, was created long ago to assign a numeric value to each of the graphic characters that we use. In it, the capital letter A has the hex value of 41, letter B is 42, letter C is 43, and so on. ASCII has places for alpha characters, numeric digits, punctuation marks, and other symbols. A lot of the symbols in later versions of the ASCII character set are not built into the TI-99. But if you're writing in assembly, nobody's stopping you from making them all yourself, or making something completely different. The more skilled you become at scanning binary, hexadecimal, and ASCII with your eyes, the easier a time you'll have with assembly. But you don't need to be able to convert it all by memory. Speaking of memory, let's take a look at the TI's memory as it's represented in the debug window of the emulator Classic 99. On this display, the first column on the left shows us the offset, the distance from 0 that the current displaying memory is located. The next 8 columns are the bytes that are stored starting at that offset, represented in hexadecimal, followed by those same bytes displayed in ASCII. If you're an assembly programmer, this display will be your best friend. Now that we know the formats that pieces of information will look like in memory, it's time to put information that we want into memory. We can store as series of numbers or text pretty much anything we want in memory. Individual byte values can be stored following the keyword byte. Values that are 2 bytes long can be typed in following the keyword data. We can refer to numbers by their decimal value or hexadecimal value, but you need to indicate hexadecimal values by preceding them with a greater than symbol. So if you have a greater than symbol followed by 0800, be sure to recognize that that number is 2048 in decimal. ASCII text values can be stored as well, using the keyword text and putting the text in single quotes. Let's look at this definition for a piece of text that we want to store. We'll label it MSG1, and it refers to a text block which contains the text welcome, followed by an exclamation point. When we're ready to use this text in the program later on, we would access it using the label name. But here's a dilemma. Registers are each only 2 bytes long. We placed the number 4 in register 0 earlier, but what happens when it's time to use that welcome string we just made? That won't fit in a 2-byte register. One of the features of the processor is the ability to access information in several ways, and those ways are called addressing modes. Sure, a register can contain an explicit value you're working with, but alternatively, it can contain an address where the thing you're working with is located. We store the address of the string. In fact, there are several addressing modes. You can access data through an immediate value, directly from a register, indirectly from a register, using a symbolic location, using an indexed location, and indirectly from a register with auto increment. If we wanted to display that welcome message from earlier on the screen, we can use the VDP multi-byte write routine, and for that we need 3 pieces of information: the location in VDP to copy it to, the location in memory we're copying from, and the length of data we're copying. We can store the welcome text together along with its length and the location to appear on the screen, and when the time comes to display it, pull in each piece of information using that one label, with a little help from the indirect addressing mode with auto increment. Here's how that works. We pull in the memory address and place it in R1, move the screen position from the R1 pointer into R0 with auto increment, and move the length from the R1 pointer into R2 with auto increment. And now both registers 0 and 2 both contain the stuff they need, and we just auto incremented R1 and it's pointing to the start of the text. We're all ready to branch to the VDP subroutine. Branch and load workspace pointer to VDP multi-byte write. That's all we're doing for now, so we just freeze the program there with an infinite jump to itself, and then end. For those of you that are familiar with TI Basic, when you tell Basic to run a program, it starts at the lowest line number, and you can really start at any line number, and if you just type the line number after run. But with assembly language, you have to indicate what addresses are acceptable starting locations. You label your valid starting points, and then using the def keyword up at the top, list all of the valid starting points. Def allows them to be linked from outside the program. We'll link our quick little program and call it greet. Since we used a built-in subroutine, VMBW, we'll have to reference it at the top in order for it to work. We'll press F9 a couple of times, make sure we have a disk inserted that has some space to store our code, and save it dsk1.greet message. We change out the disk and load the assembler. Select our source code file, create an object file with a different name, don't need to worry about listing file right now, and for options we need to be sure to include references with R. This is where it assembles our program, and it'll tell us if we have any errors. Looks like we're good. Back out to the main menu and choose Load and Run. We select the object file we created, and we have no more files to include, so press Enter one more time. Here it needs the starting program we put in our def declaration. So we put greet, press Enter, and our short little program runs. That's it. We went over some assembly concepts and syntax, as well as general use of the editor assembler. We'll play again on our next installment of the assembly series. See you next time from Newline99.